Welcome. So in this lesson, we're going to be talking about cubic functions in this form right here. So it's a brackets x minus h cubed plus k. So this is the general form that we're going to be looking at for these types of cubics. So it says for the graph of a cubic function of the form this, these are what these types of graphs are going to look like. So it's really important that you just become familiar with this shape when you have a function in this form. So cubics come in different shapes. Unlike a quadratic, which is always going to be parabolic, a cubic comes in different shapes, and it's important that you realize that if it's in this form, it's going to look like this. Now, this is very much analogous to the turning point form of a quadratic, but instead of a turning point, rather what our h and k point is going to give us is the point of inflection. The point of inflection. So we take this point, which represents horizontal and vertical translations, as we will see. That point is giving us the point of inflection. Now, what on earth is the point of inflection? If we look over here at our graph, this point right here is our point of inflection. And what it is a point at which the gradient is zero. A point at which the gradient is zero. Now, you don't need to know that until we get to calculus, which is later on. For now, all you need to know is that the point of inflection is a flat point. That's all you need to know about the point of inflection. So, just to repeat that, a cubic in this form looks like this. It has a point of inflection. Now, we can talk about the other features of this. For instance, this A is a dilation factor. So you can see how this graph right here looks a bit different to this graph. And the reason for that is because of its dilation factor. So as you can see here, the bigger the number is, the narrower it is. It's more narrow here. When this one is less than 1 and it's wider. The other difference between this graph and this graph is a reflection has taken place. And that reflection is because we've got a negative there. So that's causing a reflection. So that's another thing that you need to be aware of. This one is reflected as well. So all those key things about transformations that we have previously apply here. Okay, let's now dive into this a bit more, and we might even bring up some Desmos to help us out as well. So the instructions here are simply to, let me get rid of that. The instructions here are simply to roughly sketch each of the following, labeling the point of inflection, but not axial intercepts. Perfect. So let's give this a go. The first one is just a general cubic like this. So let's first just state what our point of inflection is. Point of inflection is going to be 0, 0. What I normally like to do is just put that flat point there, and then go up from there, and then go down from there. And let's label our point of inflection. It's going to be here, 0, 0. And now what we can do is just kind of have a play a bit on Desmos, and I highly recommend that you do this as well. Just put a cubic in this form, and then see what happens when you change the dilation factor. So if I was to make it 5, you can see it gets narrower. If I was to make it 9, it gets even narrower again. But if I was to make it 1 on 2, it gets wider. So too, if I made it 1 on 8, it gets wider again. So it's important that you have a bit of an understanding of what that dilation factor is doing when you've got a cubic in this form. All right, the next thing that we're going to do is talk about this one right here. And as you can see, what makes this one different is we've got this negative there, which is causing a reflection. So we have a reflection taking place with this one, a reflection. Our point of inflection is still going to be the same. Our point of inflection is still going to be 0, 0. And the reason for that is because we don't have any horizontal or vertical translations taking place. So the point of inflection is still going to be here, but instead it's going to be reflected like this. Now you might be wondering, why am I just saying reflected instead of saying reflected in the X or Y? And the reason for that is because there isn't a difference. So I've just stolen this line from the textbook right here. It says, note that a reflection in the X-axis and reflecting in the Y-axis result in the same graph. So, and the reason for that, if we were to think about it mathematically, is because we know that if we were to do this, so make the X itself negative, that causes a reflection in the Y-axis, right? Well, guess what? That's the same as just doing this. And when the negative is at the front, we know that's a reflection in the X-axis. So the fact that both of these are the same means it would be kind of pointless for me to say this is reflected in the X or the Y, because it results in the same graph. My graph looks horrible, but hopefully yours looks a bit better like that. And again, let me just bring up Desmos and give you a look about what's going on here. So here it is. If I was to put a negative here, it flips. So too, hopefully you can appreciate that it makes no difference if I was to put the negative inside the brackets like this. It doesn't make a difference. Oh, why can't that be a different color? There we go. So as you can see, that is the same as that. They're the same. So reflecting in the X, reflecting in the Y, it's the same graph here. All right, let's keep on moving now. Let's come on to this one right here. What's happening here? Well, what's happening here is I have this -2. And what's that doing? That is causing a horizontal translation. Horizontal translation. And that is going to affect my point of inflection. My point of inflection is going to be 2, 0. It's going to be moved over here. It's going to go up. It's going to go down. So that right there is 2, 0. That's my point of inflection. I have a horizontal translation happening here. And again, we can have a look on Desmos as to what this would look like. So if I bring this down here and I just make it like this, you can see if I make this -2, it moves like that. I can make it 3, I can make it 4. I could make it plus. If I make it plus, it moves to the left. So +3, +2. As you can see, it's moving to the left. But if I was to make it negative, it goes to the right. So those same principles that we've seen previously when dealing with different types of graphs applies here as well. We come to the next one here. And now, as you can see, we don't have brackets as we did over here. And what that tells me is this is shifting it 5 down. So this is a vertical translation down. It's a vertical translation. And you might also pick up that I have a negative here, which also means it's a reflected graph as well. So I just toss that in there as well to spice things up. Our point of inflection is therefore going to be 0 minus 5. It's going to be 5 down. So it's going to be about here. And we have to make sure that we draw this reflected. So that means it's going to look like this. And again, I cannot draw to save myself on this tablet. So hopefully your drawing looks a lot better than mine. This looks horrible. Okay, it looks something like that. And this is going to be 0 minus 5. Let's again bring up Desmos and just see what it looks like when we're moving things up and down. So we can come here, we can get rid of all of this. I can go X. I can move things down. Whoop, I'm going to have to zoom out here a bit. I can move things up. And of course I could make it negative. I could flip it. And then I could move it down, all that good stuff. So that is moving things up and down, vertical translations. All right, the last two that I want to go through here are these. And this is when I have both a vertical and a horizontal translation. So what we're going to do here is we're going to note that our point of inflection is going to be 3, 4. So I'm just reading off that and that. So I know that my X has to have its sign changed, and my Y doesn't. So that means it's going to be about here, let's say. This will be 3, 4. That's my point of inflection. I'll draw it flat there. Then it's going to go up like that. And then it's going to go down. Now, we don't have to be, let's see if I can do this again. We don't have to be that accurate here because we're just trying to get our heads around this at the beginning. So don't worry if it doesn't look exactly right. Again, my graphs just look horrible. So these should have a bit more of a, they shouldn't be going straight down. They should have a bit more curve to it. So this is going to be 3, 4. And then we can come over here. Here we have to take note of this negative, which is causing a reflection. And our point of inflection is going to be -2, -2, because this is going to cause a -2 to the left, or 2 to the left. And this is causing -2 down. So as I would come here, it's going to look something like this. -2, -2 will be about there. And it's reflected as well, so it's going to be like that, then going down, and then going up. Again, please, hopefully your graph looks better than mine. We might have a look at these on Desmos before we move on. Otherwise, you might think cubics look this ugly. This is going to be -2, -2. So -2, -2, that's our point of inflection. That's what it's going to look like. So those are like the really key basics of drawing cubics here. And again, we could bring up Desmos here and we could just have a look at this as well. So if I was to put brackets here, and then put that there. As you can see, I'm moving it up and down like this. So I can move it to this many places, and then I can move it one there. I could make this, move this up to there. I could make this -2. You know, the world is my oyster in terms of how I could move this around. And yes, so hopefully that makes sense in terms of how we're moving this thing about. Really important to note your point of inflection, where that's occurring. And in the next video, we'll go more into like drawing our X and Y intercepts into this as well. But hopefully that makes sense as just a bit of an introduction as to cubics in this form. In the next part of this video, we'll go through sketching, finding X and Y intercepts. I'll see you then.